Hello, welcome to the fourth video of chapter 9. In this video we will start using the display. Let's get started.
We've come a long way in theory, now it's time to test in practice. To help us do this, we've put together a code snippet in main.c where we can test some of the things we've learned. Our aim was to create a small project with a minimal human-machine interface, so we included the use of push buttons and LEDs alongside the display. Our main program is based on a state machine. Its states show an example of how to use our display. You can switch between states using the HMI button 2 left and HMI button 4 right buttons. In addition, we have assigned an additional function to the middle button, HMI button 3, enabling the inverting of our display. When a button press is detected, we give feedback via LEDs that our program has detected a press. However, the state change will only occur when the push buttons are released, at which point the LED is turned off. Let's start by taking a look at our state machine. For each state, there is a test function that draws or writes something on the display as named. The actual data transmission to the OLED display is done after the state selection, so that it only needs to be called in one place each time. I put the 100 millisecond delay at the end so that changes can be tracked.
I see that the states have meaningful names, but where do we find the definitions?
The definitions are given in a separate enum type, so normally the crystal clear electronics label is OLED state CCE0, the character set representation is OLED state fonts 01, and so on. Next, let's look at how the buttons and LEDs are used. At the beginning of each cycle, we scan the state of our buttons, which happens every 100 milliseconds due to the delay. Once we have the current states of the buttons, we examine them one by one to see if there has been any change from the previous state. If the state of the button has changed and is not currently pressed, then the button was previously pressed and has now been released by the user. We want to assign a state change to this event. The left button is used to decrease the status variable and the right button to increase it.
When changing states, we must be careful to manage overflow. By overflow, I mean running out of the states we have defined and to clear the display before drawing anything new or different on it.
The middle button is used to change the inversion. If the display color is inverted, the normal display mode is activated, and if normal operation is selected, the display color is inverted. To achieve the desired functionality, it is also necessary to provide feedback via LEDs when pressing the buttons and to save the state of the buttons.
Last but not least, let's review the test functions that drive the display, both at the code level and visually. Let's go through the order of the states.
The OLED test CCE displays the name of the curriculum, Crystal Clear Electronics. Set cursor is used to set the position of the text, which in this case is centered. The position is calculated from the text length, that is, the number of characters multiplied by the character width and the display width.
You can see the result on the display.
The default state of our state machine is OLED_state_CCE, which means that if for some reason our test_state variable takes a value that is not predefined, this branch will be executed.
And now, by pressing the right button on the development board, switch to the next state.
The OLED state fonts state shows the possible font sizes. 4 different sets of characters are displayed on the screen so that you can clearly see the differences in size.
The result is that the character sizes are displayed in a left-aligned layout.
We tried to make the OLED state line state, which displays the lines, a little more interesting by creating a dynamically changing screen. The code itself consists of only a few lines, but the result is a bit playful. The idea is to draw random lines between the top and bottom edges of the screen. To do this, we generate 2 random numbers between 0 and 127, which we use as the x-coordinates of the line we want to draw. We consider the y-coordinates as constants, so we fix the upper, line 0, and lower, line 63 lines. All that remains is to plot our lines. The more times we call this function, the more lines are drawn on the screen.
In practice, this is how it looks.
In the OLED state rectangle example, 5 rectangles are drawn using a loop with adjacent sides equidistant from each other.
This looks like the following.
In the case of the OLED state circle state, we wanted to show the potential of functions. In our example, we draw circles on the horizontal center line of the display, moving from left to right while increasing the diameter of the circles step by step. In the OLED state arc state, 4 synchronously rotating arcs are drawn on the display, which are rotated by 10 degrees at each step.
The result will look like this.
Last but not least, the OLED state polyline state shows an example of how to draw polygons on the display.
I will show this too. The result is a deltoid on the display, and the coordinates of the vertices are given to the plot. The starting point must also be entered as the endpoint, so that the deltoid is a completed, closed shape.
András, please invert the screen colors and step through the examples again so we can observe the differences. Also, feel free to use this feature during animations. These solutions are just examples. Feel free to experiment with how modifying the parameters affects the visual result. Even better, you can come up with your own exercises. András, what else would you try?
For example, I will draw random circles in random sizes, and at the end, I will try to draw more and more polygons. If it goes really well, I would even start making games, like Snake.
These are excellent ideas. This brings us to the end of the video and the end of the chapter. In this chapter, we have learned about human-machine interfaces and grouped them by inputs and outputs. We then focused on visual output interfaces, LEDs, and displays. We introduced the basic displays that you will probably encounter in your own projects. Finally, we covered in detail the operation and programming of a graphical OLED display. I hope you've enjoyed this chapter and found the solutions discussed useful. I hope that you have been inspired to try out your own unique ideas on your own.
Thank you for joining us again today. Remember, the written materials and example codes for the curriculum are available on the crystalclearelectronics2.eu website. If you don't want to miss out on new videos, you can also follow us on Facebook, where you get updates on new content. Bye.
Bye!